So this is problem 105 from chapter 6. You got to figure out the amount of energy needed to heat that water up first. So Q equals MC delta T. We're going to assume about 200 grams of water is being heated up. We've got a volume of 200 milliliters. So that's about 1 gram per milliliter for the density. And so then we know delta T, we know C. We plug those in, calculate it out, and we find the amount of energy needed to heat that water up. So the question's asking us how many photons are required to heat that up. Well, we know the wavelength of the microwave radiation, and so we can figure out the energy of a photon of that radiation. So E equals hc over lambda. We plug that in and we find the energy of energy per photon, the number of joules per photon, 1.78 times 10 to the negative 24th. Again, h is Planck's constant, c is the speed of light. And so now we take the answer from the previous one, the amount of energy needed to heat up the water, and we multiply that by 1 photon per 1.78 times 10 to the negative 24th joules, and we get some very large number of photons needed to heat up that water. Next part of that problem says the wattage of the microwave is 900 watts, and it defines a watt as 1 joule per second. So we know we have 900 joules per second. If we multiply that times the time, we find the total amount of energy that's needed. Well, we figured that out way back in the beginning. That was 30,932 joules. So solve this equation for T, and we find out we need to heat the water up for 34 seconds. Now, this problem wasn't assigned as part of the homework, I don't think. I could be wrong on that, but I'm pretty sure I didn't assign it. But it's a great combination of enthalpy concepts and energy or light as energy concepts. And so definitely worth your time looking at this, thinking through it.